Greetings viewers, in this video we'll go through Cambridge IGCSE Additional Mathematics Syllabus Code 0606. This is the Component 1 Paper 1, which is the non-calculator paper now. And this is based on the new 2025 syllabus of the paper just come out October-November series, and this is the first variant. So paper 1 of 0606 for the October-November winter series of 2025. So we'll do the whole paper in this one video lah. Okay, so again, this is the new syllabus. Start from this year, there is no calculator for paper 1. So I will try not to use my calculator in this video also lah. And you can see the formula booklet is pretty much the same, except they added the circle one, the circle formula. Okay, we go with question 1. So you can see calculator not be used. So first write down the amplitude and period. Okay, amplitude and period, you must remember or you try to recall, is the A cosine bx plus c, right? So for the amplitude is always the A. Okay, that's the amplitude. So in this case, the amplitude you can just write down as 3. Okay, no working to show. And for period, okay, we look at the B value. So B value is actually what we call as the frequency. So to get back the period, so you have to take the 180 divided by B, right? So that's the period T. So you take 180 or pi is fine. If the question did not specify, like here the question did not specify, you can take either 180 degrees or pi radian, right? Divided by B. So in this case, is 180 divided by 3, that is 60 degrees, or you can do pi over 3 radian. Okay, so that's question 1. Question 2, we want to sketch the graph of this same function here, 3 cosine 2x. Okay, so first of all, you see there is a plus t, right? The plus t, what it means is the center line. So center line is a -1. I would just try and sketch out the center line first. So here is a -1. Use your ruler in the real exam. And so if you remember the shape of the cosine graph, you can just try and draw at the side here. It will be starting at 1. Then you go to 0 at 90 degrees, -1 at 180 degrees, then 0 again 270, and then finally it come back to 1 at 360 degrees. That is the normal graph lah. So in this case, the period is 180 as we established already. So meaning it will shrink, or okay, it will appear twice in the 360 degrees. So that's why with the B, actually we call it as the frequency. So and then also we have the amplitude. So amplitude meaning is the distance from the center line, right? So usually it start from 1, but now it start from -1 plus 3. So it will be starting at 2. And then it will end at 180. So it will end here. Okay, in the middle we split into 4 parts. So the first quarter it will go back to the center line. Second quarter it will go back to, what is the -1 minus 3, right? So -4. The third quarter it will go back to the center line. Finally it come back here. So we do the same thing for 4 quarters on the 180 to 360. So be mindful of the range. Sometimes they try to trick you, so you must draw according to the range. We only want to 0 to 360. Okay, so now we can try and sketch it out. So please do not use straight line. Try and connect as best as you can with freehand. So a smooth curve. Okay, something like that. As long as the shape is okay and you do not use the straight line and you have the critical point at the center line and at the intercept, alright, so this will be the cosine graph. Okay. Okay, question 2, find the set of value of k where this straight line meets the curve, the quadratic line at the 2 distinct points. So remember, 2 distinct point, what is it? That will be using the discriminant value. So if you look at the formula sheet here, I think they given you is the quadratic formula, right? So the quadratic formula have this plus minus square root, the thing that is inside the square root that we call the discriminant. That's why if two distinct point, they will have a value here, right? Because there will be plus and then also minus answer. So if there is only one answer, means this one is 0 lah. Okay, so 2 distinct point meaning what it means? B square minus 4AC is greater than 0. So we try and do the equation first. Okay, so meaning we equate these two, okay? Kx minus 3 equal to x squared plus 2x. Then we try to rearrange. Okay, in this case, what is the a, b, and c value? Okay, usually we have in this form, right? Ax squared plus the b x and then plus the c. Then we equal it to 0. So in this case, the a is just a 1. B, we take this whole value here, 2 minus k, and c is 3. So, okay, b squared, 2 minus k, the whole thing squared, minus 4, 1, and 3. So we want it greater than 0. So this one you expand, and this one you try to multiply, and you should be able to get a quadratic, right? A quadratic in terms of k. Okay, a 3-term quadratic, k squared minus 4k minus 8 is greater than 0. So what this actually mean is this quadratic inequality, right? If you recall, it means we want what is the value of the k that will get the quadratic graph that is on top, right? Greater than 0 means on top of the x-axis. So this part. So we want on the left and on the right side. So what we need to do is we want to find what is this value and what is this value. Okay. So if you can try and do this, is not able to be factorized. So what we can do is instead we use the quadratic formula. Okay, so if you forget, you always can refer to the formula sheet, it's given. Otherwise, you can just copy it. AB squared minus 4AC divide 2A. And they want the answer in the simplest third form. Okay, so we'll keep that in mind also. So again, in this case, the B is negative 4. So negative 4 is positive 4 plus minus 4 squared is 16. 4, 1, negative 8. Okay, so there's no calculator again. You have to be quick in your arithmetic also. So 4 plus minus, inside here you try and calculate. It should be 16 plus 4, negative 4 multiplied negative 8, that is 32. So 16 plus 32, 48 divided by 2. Okay, so 4 divided by 2 I can just take as 4 plus minus, and this I want to take this divide 2 inside the square root means I need to square it. So 48 divided by 2 squared, which is 48 divided by 4, 12, right? And 12, what I can do is I can split into 4 times 3. And 4 is 2 squared. So the 2, I can take it out of the square root. So 2 square root 3, like that. So what happened is on the left hand side here, there is a 2 minus 2 square root 3. And on the right hand side is 2 plus 2 square root 3. So our k value is, k is smaller than 2 minus 2 square root 3. And k greater than 2 plus 2 square root 3. Okay, so that's the possible value of k. Okay, so that's question 2. We move on, question 3. Solve this equation. A logarithm log base 2x minus 4 become or equal to 5 log 2 base x. Okay, so we definitely need to change one of the bases so that we can try and solve it. So maybe I can try to make this one into or I'll try to make this one into log base x lah. Okay, if you can try and recall also, if you have a log maybe a then base of b, then you want to change the base, so we have a log on top and then a log on the bottom. Let's say we want to change the base to base b. Okay, so what happened is the a will go on top and the b will go on the bottom, right? So something like that. So in this case, what we want to do, maybe here I want to change to log base of x, so that everything is in one term lah. So meaning log x divide log x, and the x will go on top, and the base 2, the smaller number, go on the bottom, right? So that's what happened here. Minus 4 equals to 5 log 2 base x. Okay, so if you recall also one of the logarithm rule, log x base x, this one you can just cancel to become 1. So I have 1 divide log 2 base x minus 4, 5 log 2 base x. So I will try and multiply the whole equation on both sides by log 2 base x. So, okay, on my right hand side, you have to be careful here. This one become a log 2 base x squared, right? This one is supposed to be log 2 base x. Okay, so this one is on the right hand side become a square. And if you have learned also one of the log rule, okay, log x power n, this you have this one meaning the n, the exponent you can bring forward, right? So you can multiply by the logarithm. But in this case, um, the square here is on the outside of the logarithm, so it's not attached to the argument of the logarithm here. So we cannot, in this case, we cannot do that. So we have to treat this as a quadratic equation in terms of log base 2. So we rearrange, so hopefully you can try and see clearly. Okay, and yeah, it should be more clearer now. Now it's quadratic, and we can try and factorize it. What we need to do is, okay, I have no space here, so maybe I come up to here. Okay, so on the, I'll deal with the 1 over 5 here. So we raise both sides by power x, right? So x power 1 over 5 equals to 2. And to get rid of the 1 over 5, I power both sides by 5. And this becomes x power 1 and 32 on the right hand side. And the other one, log 2 base x equals to negative 1. Maybe this is a bit confusing. So this arrow, it will come from here. Okay, and then this one I put as blue color. Right. So here become x power negative 1 equals to 2. So x power negative 1 is 1 over x, 2, and x you rearrange become x 1 over 2. Okay, so this is the two answer. X is 32 or x is half. Okay, that's question 3a. Question 3b, another exponent question. In this case, you have 2 e power x squared minus 3 and 25. E power 7 minus x squared. So let me try and rearrange this. And this 25, I want to try and write it as an exponent. So if you recall, this is one of the rules that you have learned also. So you have e power the natural log, it will cancel out both of each other, and it will actually just be equal to x. So I will use this same principle. X I will replace with 25. So it means e power natural log of 25, that will be 25. So these two is the same. Okay, try and convince yourself this. So I will write out the entire equation, okay, on both sides here. And if you recall also one of the exponent rules, same base I can add the power. Same base multiply, I add the power. So this whole thing become 7 minus x squared plus natural log of 25. Okay, on the left hand side, I remain the same thing. I did not do anything to it. So now on both sides, it's just the power of e. Okay, e power something. I take the natural log on both sides. Natural log on the right hand side also. So it will cancel out, and I'm left with just the exponent I can equate to each other. This is just I rewrite the exponent, right? And now we can rearrange 2x squared equals to 10 plus natural log of 25. So x squared 5 plus half of ln 25. Okay, so this half I can bring on top to the exponent, become a square root. So 5 plus ln 5. So this x squared. Finally, x is, you can take the square root on both sides. 5 plus ln 5. And this will be your final answer, right? Because x, it can be a positive and negative value. There's no restriction on the domain here. So yeah, we can accept both plus and minus. So but some question you have to be careful. If it's a logarithm, I think the argument of the logarithm cannot be negative. So you have to be careful. In this case, exponent you can accept any domain. Okay, 4a, why is it not a function, right? We gotta recall a function is only a one-to-one function where one value of x can only have one value of y. In this case, let's say one value of x, okay, maybe I try and draw a straight line. One value of x, you can see there is a few values of y. One value of y also have a few values of x. So this one is not a one-to-one function, right? So part B, the table show graph of four different functions. So again, this one, is it a one-to-one function? No, because again, one value of x, let's say here, sorry, one value of y, okay, you have a few different value of x. So actually, so it's a many value of x mapped to one function of y. So this one, okay. Second one, is it a one-to-one function? Yes, because one value of x is only mapped to one value of y. You can see the horizontal and vertical line test, you only intersect once. So it is one-to-one. And is it a own inverse? You can try and sketch the y equals to x, the diagonal line, and it is a reflection, right? So yes, it is its own inverse. This one again, you draw the horizontal line test, it intersects a few points, so it's many to one. Last one is a one-to-one, yes, but it's not its own inverse because you can try and draw the diagonal line. Again, it does not reflect correctly. Okay, so this one should be the only answer. Part C, continue on the function topic. So you have f and g of x given this domain, and it's given that the function gf exists, and they want you to find the value of a such that the domain of gf is as large as possible. Okay, let's try and express gf as a function first. Gf of x, so it means a g sine of x. Okay, remember the inside function always go first. So it's a okay square root sine x minus half. You can try and recall that the inside of a square root, it must be greater to or equal to 0. Okay, so we can try to extract this information. Sine x minus half greater to or equal to 0, which means sine x must be greater to or equal to 0. And if you can recall, so this is the domain given us, 30, and it's given us also, sorry, wait, here is 1 over 2, 1 over 2, not 0. Okay, sine 30 is 1 over 2, so it's so good they give you this relation also. Okay, and if you can try and sketch out, we recall what is the sine graph look like. Again, it look like this. So sine 30 is here, so it give you half, and then 90 is at 1, and 180 is at 0 again. And if you recall also, sine graph is symmetrical. So symmetrical meaning that from 180 to where it get to 1 over 2 again, you just have to minus 30 degrees, right? So this meaning that wherever that in between these two values, this sine x will be greater to or equal to 1 over 2. So that is the allowable value of x such that sine x is fit the domain of g, so that this function exists. Which case, right, so yeah, what is the value of this angle here? Maybe we call it, it's already given, right? A. What is the value of A here? A will be 180 minus 30, because symmetrical, right? So minus 30, so 150 degrees. Okay, so this is the answer for part 1. Okay, for the domain of this value, okay, for the domain of the function, in part 1, find the range of GF. Okay, we know also Okay, we know the two extreme limits already. Sin x can be go up to 1 or it can be 1 over 2. And that's the two extreme limits already. So uh, let's say GF, it will be in between two values. And the greatest value, it will be when sin x is 1, right? So it will be square root 1 minus 1 over 2. 1 minus 1 over 2. So, and the smallest value, it will be when sin x is 1 over 2. So 1 over 2 minus 1 over 2. So here will be, on the left hand side, it will be 0. And on the right hand side, it will be square root 1 over 2. And the range we include, or is inclusive of both these values, because it's given also, or here the signs are inclusive. So we just take it as the inclusive. Okay, last part. Determine whether the function g square exists. So g square, if you can recall, it doesn't mean that you square the square root. No, it means g of x. So you have a g of square root x 1 over 2, x minus 1 over 2, and then you do the same thing again, x minus 1 over 2 minus 1 over 2. So does this exist or not? No. Okay, no, it does not exist, because why? For this function to exist, g, the range of g must fit the domain of g also. And if you can recall, for a square root, okay, so what does a square root function look like? It looks like this. It will keep going up. So even if you have the, yeah, it did not specify a largest or maximum of x, so we can assume that it will go, or the y, right, the range of g will be all real numbers. And so all real numbers does not fit, okay, does not fit the domain of g, which is x must be greater equal to 1 over 2. So it does not exist. Okay, it doesn't exist. Okay, arithmetic progression, question 5. The first term is 3, so that is a. And the sum of the first 10 terms is 4 times the sum of the first 5 terms. Okay, so yeah, we need the formula sheet for this because I don't remember. Okay, so we use this one. So we have two different formula we can choose, but we will choose the second one because we don't know what is the last term. Okay, we have the difference. Sorry, we don't have the difference. We have the first term when we have the n. What is the term that we want to find, right? So we can, let me try and copy down this formula first. Let's say n is 10, so I will substitute here on this side first, while everything n is 10. And 2a, a we know that is 3, so we can substitute as 6. Then n minus 1, that's 9d. Okay, then 4 multiplied half, and in this case on the right hand side there is 5, right? S5. So 5, 2 times a, that is still 6. 5 minus 1, that is 4d. So we must be careful when you substitute the formula. You should be able to get 5d is the d, so d result in 6. So that's the, that's the what we want to find. That's the common difference. Alright, okay, next part. 5b, the first, second, and fifth terms of another arithmetic progression is the first, second, and third term of a geometric progression. Okay, so u1, I will use u as a geometric, and t I will use as the arithmetic. So u1 is t1, and that's the first term, so I can just use as a. So doesn't matter, they share the common first term. Okay, so that's just a. So u2, that is t2 also. Okay, u2 maybe I can write as ar, and t2 I can write as a plus d, right? So you just add one of the common difference. Okay, u3, that will be t5, right? t5. So ar squared, which will be equal to a plus 4d. Right, I think first we can use these first two equations to deal with some. We can eliminate some of the terms here first. Oh, okay, we don't even need the first equation. I think we can just use this one. So I'll isolate D. Okay, I think I can isolate D. So AR minus A. And we will substitute this D into this equation. The U3 equals to T5. So AR squared equals to A plus 4. And D I will substitute as AR minus A. And you can see we can factorize out the A because the A is multiplied into each of the terms, right? So I'll factorize it all out. And you can now see it's the A multiplied by a quadratic equation in terms of R equals to 0. So if you can recall another of the mathematical rules, right? If you have two terms multiplied together to become 0, one of them must be 0. But as okay, presented in the question, also some of the basic thing you need to know, the first term of a geometric sequence cannot be 0. Otherwise, you multiply by anything multiplied by 0, that's still 0. So it's not really a progression. So A cannot be 0. So this one must be 0. The quadratic equation must be 0. So since A cannot be 0, okay, so r squared minus 4r plus 3 equals to 0. I think we can factorize. Yep, r is equals to 3 or r will be equals to 1. But again, you can try and check your knowledge and convince yourself of this because a geometric series, if your common ratio, so means the thing that you multiplied with each other is 1, so it's not going to be a progression, a geometric progression, because it will still be the same uh, what we call same term over and over again. So 1 multiply anything it does not change the number. So that's why it's also written in the question, right? R cannot be equals to 1. Okay, so yeah, that's what the question wanted us to find. So that's the part B done. And yeah, please reject this solution. So this is the only answer that we have. Okay, question 6, we want to solve this equation. Remember for modulus, what it means is it can be either the positive or negative version of the number. So either x squared plus 5x equals to 6 or negative x squared plus minus 5x equals to 6. Right, so that's what the modulus means. It can be positive or negative. Yeah, we try and yeah, these are both quadratic equations, right? So we have to solve them basically. So 4 solutions here. Okay, 2 from each. Okay, question 7. So now is move on to calculus. And here is given us a quotient and we want to differentiate it. So yeah, you can try and recall the quotient rule. So if a u divided by v, what's the rule? I think we leave v first and we differentiate u. Minus, okay, so the order matters because there's a minus here, and we differentiate v and leave u. So then divide by a v squared. So I don't think it's given, right? It's not given in the formula sheet, right? So and none of the uh, differentials are given also. So for IGCSE level it's not given, but I think yeah, for later on in your A levels it's all given. And yeah, all the differentials is given. But yeah, we won't refer to this for now. We'll just proceed without it. So again, we differentiate this. So we differentiate the whole thing. We leave the bottom first. So e1 minus 3x. Then differentiate the top. The top, okay, sine become cosine. Cosine become a negative sign. Okay, now we minus, differentiate the bottom. So, okay, it's an exponential, so we just leave the exponential first. 1 minus 3x. And we need to differentiate the inside function, chain rule, right? So differentiate 1 minus 3x, it becomes 3x. Sorry, negative 3, just negative 3. Okay, and multiplied, we leave the top function. So u is cosine x, sine x plus cosine x. Everything divide by this one, and you square it. So I think you should be able to leave the answer like this, but if you want to simplify it further, sure. So since this is a squared, this one, both of these can be removed, and you're left with cosine x minus sine x plus 3 sine x plus 3 cosine x divide by e1 minus 3x. So 4 cosine x plus 2 sine x e1 minus 3x. Okay, so yeah, you should be able to leave it like this, but if you want to simplify, this is a nicer answer. Okay, now it's an integration question. And from what I recall, you should not be able to, or at your level, you should not be able to directly integrate a tangent square term. You should be able to make use of some previous knowledge from trigonometry to try and manipulate this in the form that you can recall how to integrate, right? So tangent squared, this one is one of the Pythagorean identities. So here, yeah, 1 plus tangent squared is equivalent to a secant square. So 1 plus tangent squared, or 3x of 3x, I can rewrite this as the secant square of 3x. Right, and then this one, you should be or it should be familiar to you directly to integrate it, because we know that the derivative of tangent is secant squared. So this one, from secant square, you integrate, just become a tangent, 3x. And don't forget to divide by the derivative of the 3x, the reverse chain rule. Right, so divide by 3. And since this is an indefinite integral, so we have to add the plus c behind. Okay. Okay, solve the simultaneous equation. Okay, this pair of simultaneous equation. So some algebra. Yeah, I think since you already isolated x for us here, we'll just use this and substitute into x for this equation. Okay, so 1 minus 6y divided 2y, 4y, 1 minus 6y, negative 1. Okay, so all I've done here is replace the x with the expression that is given us. Now what we can do is we can do the cross multiplication so that I can combine the denominator of the fraction. Okay, so I have 1 minus 6y squared and then minus 4y times 2y divided by 2y, 1 minus 6y equals to negative 1. So now we do the expansion of everything. 1 minus 12y minus 36y squared minus 8y squared. And then this one I'm also going to directly bring it to the right hand side. So I have negative 2y plus 12y squared. Correct, yeah. This one is plus 36, not minus 36. Okay, so yeah, correct. We try and collect the terms first. So 36y squared minus 8y squared, and minus 12y squared again, so that is 16y squared. And 12y squared plus 2y squared, 10y. So 1, and yeah, just leaves 1. Then yeah, can we factorize this? Should be able to, right? 8 to y minus 1 minus 1. Yeah, so y will be either 1 over 8 or y will be 1 over 2. For which this one you should be able to substitute back into this equation. And here will be 1 minus 6 over 8, and here will be 1 minus 6 over 2, is it? Yeah. So, sorry, this x, not y. So here will be negative 2, here will be 1 over 4. Okay, so yeah, the solutions come in a pair. So these two come in a pair, these two come in a pair. Okay, so there's the answer for part 8. Okay, question 9. Now we have moving on to kinematics. So this is a VT graph, velocity time graph. Okay, and you want to sketch the speed time graph. Okay, let's recall what's the relation between velocity and speed. Right, velocity is a vector quantity, whereas speed is just a scalar. And speed is the magnitude of the velocity. Right, so velocity is just the speed together with the direction. And in this case, we can notice that there's a negative velocity here. So what that essentially means is that um, is moving in a direction away from, or in this case, whatever the negative is defined to be. So it's moving in the negative direction. So for speed, we don't really care about the direction. We just care about the magnitude, for which that you just take the absolute. I mean, yeah. So speed will be just the absolute value of the velocity, right? So this is the relation. So if you can recall, how do we plot the modulus graph or the absolute value graph? You just reflect whatever that is in the negative axis. You just reflect it on top. Okay, so we will try to do this as accurately as possible. So the axis intercepts at around 1.4. So we'll do that also, and it's kind of a curve towards, right, a curve towards the y-axis, and then this is a curve away. So it's not a straight line. So we try and reserve the shape as much as possible so it curves upward. Okay, so there's just a sketch, right? Just to show that you understand that you need to reflect this and don't lose too much of the shape. Okay, it's given that this velocity time graph is part of a quadratic curve, right? So that's why it's a curve, not a straight line. And the curve has gradient 0 and time is 0. Okay, so actually this part, gradient is 0. Okay, so we want to sketch the acceleration time graph of this particle. Okay, so if you can recall, okay, one of the relation, A is dv dt. So it is given us that dv dt at t equals to 0 is 0. So we definitely have to start, that means A at 0 as a start at the origin here. And we look at the quadratic curve. The gradient at this point, okay, maybe I try to sketch a tangent graph, a tangent at this point compared to a tangent at this point. Okay, so we can see that definitely the gradient is increasing. Okay, don't mind how bad the tangent is being sketched, but the gradient is increasing as you can observe also. So it will be a straight line going upwards, right? A straight line going upwards. So you don't have to do any value or what, it's just a sketch. So as long as you start from the origin and it goes upwards. Alright. Question 10. Okay, you see like this, you should straight away know what you want to find the shaded area, right? So find the area of the shaded region. It's given a quadratic curve and also a straight line L. But they did not give us L. What information that they give us is the normal to this curve. Okay, line L is the normal to the curve at x equals to 5. Okay, so at 5 here, the gradient is the perpendicular to the gradient of the quadratic. And we don't know what this point is. Yeah, we can try and do the we can try and find the points. This point where the root of the quadratic graph and the line L intersects. Okay, so to find the roots, we equate the quadratic to be equal to 0, and we can try and see if we can factorize them. Yeah, we can. So 3 and 6. So x here will be 3, x here will be 6. Um, so yeah, there's a few ways you can find the equation of L, because if you know, or if you prefer to do the differentiation of y, and then you do the substitute x into the dy dx to find the perpendicular gradient, that's fine also. But what I'll do is, since we already know that this point here is 5, uh, what we can do is we just substitute 5 into y, okay? Then we know that this point here is 3, 0, so we can easily find the gradient of L, okay? So yeah, when x equals to 5, so what is the y value? So y will be 25 minus 45 plus 18, which will be negative 2. Okay, so here is 5, negative 2. So the gradient of L -2 minus 0, 5 minus 3. So -1. And from that, we substitute into the straight line equation, y equals to -x plus c through, yeah, you can go through any of these points, but I'll do 3, 0 for simplicity, where c you can able to find to be 3. Okay, so not that it's important, but this point is 3. Okay, and all we need to do now is we do the integration, right, to find the area. So either way, you can take the quadratic minus the straight line or the straight line minus the quadratic, it doesn't matter, because what you're doing is you're just finding the difference of the areas when you integrate. Right, so area will be the integral from, what's the value, 3 to 5. Okay, so of, but I think you've been taught always the top one minus the bottom one, right? And later you'll see why that's not really, okay, it doesn't really matter after we do the integration. But okay, let's do the top one minus the bottom one. So L was L, so -x plus 3, then we minus the quadratic, x squared minus 9x plus 18. So this whole thing we do the integration. Okay, let's simplify the integrand first. So we have a -x squared plus 8x minus 15 dx. Don't forget the limits 3 to 5. So okay, remember to integrate you add 1 to the power, so 2 plus 1. So that's 3. And divide by the new power, so divide by 3. Here, power 1, add 1 to the power, so x power 2, divide by 2, so 8 becomes 4. And in this case, 15 is a constant, which means it's a x power 0. 0 plus 1, so that's just a x power 1. Okay, and we have the limits, so we don't have to add the arbitrary constant, so we just plug in the limits. Okay, so 5 cubed, this is the thing that you need to recall immediately now. So it's something like 125 divided by 3, 5 squared, that is 25. Then 15, 5. So this whole thing, okay, the top limit minus the bottom limit. So 3 squared, 81. Then divide by 3 again, that will be 9 lah, right? So 4 times 9, 15 times 3. Okay, do a bit of simplification. -125 over 3, we'll leave that first. 4 times 25 is 100, minus 15 times 5 is 75, so 25 here. Minus of 81 over 3, that's 9. Minus 9 plus 4 times 9, 36. 15 times 3 is 45. Okay, so 125 over 3, 25. Okay, this second term we can completely solve. Minus 45, 28, if I'm not mistaken, 28, right? Okay, sorry, this second part you get 18. Okay, so 18 and 25, so 43 minus 125 over 3, so we do the conversion, 129 over 3, 125 over 3, yep, so 4 over 3. Okay, so the area will be 4 over 3 units squared. Yep, okay, so that's the final answer for this question lah. And I think I was mentioning previously why we actually it doesn't matter if you do the other way around. If you do the quadratic curve minus the straight line curve, you will get the same magnitude of the answer because it's just the difference. Again, it's the bigger area minus the smaller area. But in this case, it's negative. So if you do the quadratic minus the straight line, you will just get a negative value. So you can just take the absolute value of that and you'll get the same answer. Right? You can try and convince yourself of this. Okay. Okay, number 11. The permutations of n items taken 4 at a time is equals to 1/6 of the number of permutations of 2n items taken 3 at a time. So permutations, right? So np4 is equals to 1 over 6 of 2n p3. Okay, so there's the permutation, and we'll refer to the formula sheet. You can try and see that there's no formula for permutation. All you have is the formula for combinations here. So actually, it's pretty simple. So combination, you just have this extra r factorial term on the bottom, whereas permutation, you just don't have this. So for permutation, it will be npr, it will be n factorial over n minus r factorial. Okay, so that's the trick in the formula sheet here. So you can refer to this combination one, just remove the factorial r. So n permutate 4, it will be n factorial divide n minus 4 factorial. Then this 1 over 6. So 2n factorial on the top, 2n minus 3 factorial on the bottom here. Even though this type of question is not new, we've done multiple times before on this channel, but we can try and recall what this actually means, right? So 2n factorial, that is the same thing as 2n multiplied by 2n minus 1 multiplied by 2n minus 2 and so on and so forth, right? Maybe I write a few more times. So yeah, 2n minus 3, 2n minus 4, and so on and so forth until you get to 3, 2, 1, right? Which is the same thing like 5 factorial. There's 5, 4, 3, 2, 1. So 5 and 5 minus 1, 5 minus 2, and so on and so forth. Same thing here, 2n minus 3 factorial. There is 2n minus 3 multiplied 2n minus 4, so on and so forth. Okay, so if you have this 2n factorial divide by the 2n minus 3 factorial, okay, on both sides, let's see that this 2n minus 3 cancel out, 2n minus 4 cancel out. Okay, so what is left is only 2n until 2n minus 2. I will write the result here. I will just directly write the result here. So 2n minus 1, 2n minus 2. That's on the right hand side. On the left hand side, I'm not going to show you the long working. I'm just going to directly write the result. You can try and do the same thing here and practice doing the cancellation. So I will just have n minus 1, n minus 2, n minus 3. So n minus 4 is being cancelled off already. Okay, so all we need to do... Okay, before I even do the expansion, I can even do some cancellations some more. Right, so this n and n can cancel. So I'm left with 2n minus 1, n minus 2, n minus 3, 1 over 6. Okay, but not yet. Here, this 2n minus 2, I can factor out the 2 here also. So I have 2 over 6, 2n minus 1, and then n minus 1 here. Right, so this one, the 2 and the 2 are factorial out. I'm left with this one. So n minus 1, n minus 1 on both sides. I'll cancel it, and I'm left with 1 over 3, 2n minus 1. And on the left hand side, I can just expand the bracket. N squared 5 and 6. Okay, from here I'll just expand and simplify on both sides. So 3n squared 15n 18 2n minus 1. Oh yeah, I've missed out here. This 2, okay, this 2 is gone here already, but then this 2 I factor out again, so I'll have an extra 2 here. So here becomes 4. So here becomes 4. Here becomes 2 over 3. And yeah, on my right hand side here becomes a 4 and 2. Alright, okay. So 3n squared and 19n plus 20. Okay. So this question is good so that you can actually check your final answer, so if it adds up or not. So yeah, we have proven this, so just write proven. Okay. Hence find the value of n. Okay, sure. We can try and factorize it. N equals to 5 or n equals to 4 over 3. So in this case, n is some number of items, right? So it must be an integer. We cannot let it to be some non-integer. So we must reject the fraction. So it must be a whole number of items. Okay, so otherwise it doesn't make sense already. Okay. Okay, finally, question 12. So there's a vector question and we will not accept answer by drawing. Okay, relative to origin O, A, B, and C, they are, okay, let's sketch this out. 1, 7, somewhere here. 7, 4, somewhere here. So that's B. And C we don't know, but K is a scalar constant and is in the direction of 1, 2. So it's a somewhat a steep line. So C can lie anywhere on this straight line, right? It's something like a straight line formula, y equals mx plus c. Okay, given that C lies on line AB, okay, so AB is here. Okay, so given this is AB and this is C, C must be here already. So by drawing, that's where it is. But they don't accept by drawing, so we have to find out the vector of the ratio AC and AB. So first let's try and find AB. Okay, AB, if you can recall, there is AO plus OB. So AO is negative A, right? So negative 1, 7, 7, 4. So AB is just a 6 over negative 3. And we try and find AC also. AO again, 10 plus OC. So AO negative A plus K1, 2. So K minus 1 and 2K minus 7. Okay, so that's AB and AC. We found these two vectors. And we also know that uh, C lies on AB. So meaning AC and AB, they are actually collinear, which means which means they are scalar multiple of each other, right? So we let lambda, okay, usually it's lambda, right? Lambda be a scalar multiple, and since AC since C lies on AB, AC and AB are collinear, so this must be true. Okay, AC is a scalar multiple of AB. Okay, so K minus 1, 2K minus 7, you can equate this to lambda 6 minus 3. And yeah, so for in vector form, you can actually equate just the I and J component. So I and J, we can take it as separate equation. So K minus 1 equals to 6 lambda, 2K minus 7 is equals to negative 3 lambda. And actually, you can just solve, right? You can just solve using this simultaneous equation. So K, from this first equation, I'll isolate K, 1 plus 6 lambda. And yeah, I will substitute into the second equation. So 2, 1 plus 6 lambda, minus 7, 3 lambda. Okay, lambda I can able to find as 1 over 3. Okay, so we know that AC is 1 over 3 AB. So AC is like 1/3 of AB. Where so AC or the ratio we can do as like 1/3, something like that. Okay, is that yeah? Okay, so question 12 is the last question for this paper, and yeah, thanks for watching this video. So all the best in your studies. Right.